Okay, folks, we're going to be doing 3.1. This is all about linear equations, graphing. We've done some of this, but we're starting with proportional relationships. This is 3.1. Our objective, I can analyze equations, linear graphs, and tables, to find unit rates and compare proportional relationships. Vocab will be proportional relationships, unit rate, and slope. Actually, I want to change this unit rate to rate of change. My bad. Got to update that file. Okay, so what we have here, we have three functions. We have function A, function B, and function C, and we have three different representations of each function. We have an equation for function A, and that's it. We're going to fill out the graph, we're going to fill out the table. For function B, we don't have an equation or a table, but we do have a graph. And then for function C, we don't have an equation or graph, but we do have a table. So we're going to kind of like use this information to fill out the rest of these representations, or create the rest of these representations. So yeah, let's get to it. So when we have an equation like this, y equals 3x, I find it, I don't know, let's fill out the table first, right? So the idea here is we're going to take, we have a y, we have an x. So we're going to do, we're going to fill out some x's, some inputs, then we're going to take those numbers and we're going to plug them into the equation to get our outputs or our y values. So my graph here starts at 0, so that's kind of an indication that I'm going to start with 0. Now I'm going to go just kind of fill in like so, go up through 4. And so what I'm going to do is I'm going to take this x of 0, plug it in, so it becomes y equals 3 times 0. Let's see if I can kind of just do a little bit of work right there. And then I'm going to do 3 times 1. I'm going to do 3 times 2, 3 times 3, and 3 times 4, right? And I'm just taking the x value right here and plugging it in for that, that x right in the equation. So 3 times 0 is 0, 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12. You can see that the pattern here is that I'm going up by 3 on my y values each time, because that's the coefficient of the variable right there. All right, so I've got my table right here. We generated it using the equation. Now I can, now what I'm going to do is I'm going to use this table to fill out the graph, right? So I've got 0, 0 right here. Okay, and then I go over to the right one and up 3. Right, that's my x, it's my second coordinate point right there. Then over 2 and up 6, right there, over 3 and up 9. And then the last one would send us off the graph, so we don't need to worry about it. Now I'm going to use a straight edge here and draw my line. Okay. Now, since our equation is like this, I could put in really any x value right here, like an infinite number of x values. I could even go negative if I wanted to. And what would happen is that this line would go on infinitely in either direction. That's why I have the arrows on it, and that's why it's drawn fully across the grid. Okay. What is the rate of change? What is the slope? Well, the rate of change is we're going up 3 and over 1, up 3 and over 1, up 3 and over 1, right? That's right from our equation, and we can see that we're going up by 3 each time, so plus 3, etc. And these are going up by 1 as well, so 3 over 1. All right, so rate of change is, let's do rate of change is 3 over 1, or 3. And then what is the slope? Well, it's the exact same thing. So slope, or the m value, that's the variable we use, is 3. Okay. Now for function b, right here, we don't have an equation, we don't have a table, but we do have a graph, right? So what I'm going to do is I'm going to kind of figure out some points that I have, right? So I have a point at 0, 0, right? And then I kind of go through here and I figure out where the line goes through a corner of the graph. I don't want to choose this point right here because it's halfway and it gives me a fraction. I mean, I could do that, right? So for every x, or if I have an x value of 1, that would give me a y value of 1/2, right? But we want to try to do whole numbers when we can, just because it makes our, visualizing of this easier, right? And then I have a point right here. Oh, this is over 2 up 1, by the way. Okay, and then this is over 4 up 2. Okay, and then this is over 6 up 3. And then we would go off the grid here, we'd go up to 8 and then 4, right? And so you can see that for our x value, our y value is half of that, right? So as our y values are going up by 1, here, our x values are going up by 2. Right? And so in the previous one, we had a vertical change of 3 and a horizontal change of 1, so this became 3 over 1, so rise over run. Right? This is going to be a vertical change of 1 and a horizontal change of 2, so a rise of 1 and a run of 2. So when we put this together, it's going to be 1 over 2x. Okay? So yeah, there you go. So what values or what numbers did you choose for your x values or inputs? Well, I chose even numbers. I went up by 2. Up by 2's. So for instance, 0, 2, 4, 6, 8. And the reason is because it gave us whole numbers for our outputs or for our y values, because it generates or gives or makes whole numbers for our y values. And of course, right, we could change it from I went up by 2's for our inputs for our x values, because it generates whole numbers for our y values or our outputs, right? Inputs are x values, outputs are our y values. Now, what we got right here, we have our table. So I'll generate the equation first based on this. And so what we do here is we figure out what the change in our y values is. We're 4 there, 4 here, 4 here, 4 here. So our rise is 4, and then our run is going up by 3 each time. So this is our run. Okay, so we have a rise of 4 and a run of 3. So our slope, right, is rise over run, which is 4 over 3. And remember, our equation is y equals mx, right? And so this is going to be y equals 4 thirds x right there. Oops, sorry. So rise over run, the rise is 4, the run is 3, so that's where that 4 thirds comes from. Now we're going to generate our table. We're not adding anything to it, and we know that it goes through 0, 0 right here, so it's proportional. So we're going to start right here. Okay, that's our starting point. You can kind of imagine that there's an invisible plus 0 right here. And so what we do is we go up by 4, because that's our rise, and right by 3, because that's our run. We're going up because this is positive. Okay, so 1, 2, 3, 4, and then over 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. And that's all we got, because we'll go off the grid otherwise. And then we can see that that this point 3, 4 is right there. This point 6, 8 is right there. This point 9, 12 is right there. Okay. Okay. Why did we skip count by 3 in this table? Well, if we did other numbers, we would get fractions. So if I chose 1, 2, 3, 4, if I go over by 1, it's actually up by here, so it's like 1 1/3. And if I go over by 2, it's kind of like in the middle. You can't see. 1, it's actually a little bit above here. If I go 2, we can see that it's in the middle, right? 3 gets us a whole number. Okay, so we skip count by 3's, because that gives us a whole number, right? That basically, when we plug those 3's in here, those multiples of 3, the 3 on the bottom will get eliminated and give us a whole number. Skip count by 3 in the table because it gives us whole numbers. Yeah. Whole numbers for our outputs. Let's see. Let's say. Okay. What is the difference between rate of change and slope? Well, when you have a proportional relationship, there is no difference. Okay, so with a proportional relationship, Okay, rate of change and slope are the same thing. Okay, which function has the greatest slope? Which one has the least? How do you know? Well, it's when we're talking about things like this, when we're comparing slopes, we talk about the steepness of the slopes, right? So this is clearly the steepest. So if you were walking up this slope, it would be the hardest, right? Because it'd be really, really steep. This is the easiest. This is kind of like in the middle. And you can also see that 3 is bigger than 1/2, and 3 is also bigger than 4/3, right? Because this is 1 1/3 if we talk about it as a fraction. So biggest number for the slope means that the line is steeper. So function A has the greatest slope. Um, 1/2 is the smallest value, so function B has the least slope. So maybe a weird way to say it, least slope, less steep. Function B has the least slope, smallest maybe. How do you know? I know because 3 is greater than 1/2 and 4/3. How do you know these are proportional relationships? Very simple. They start at 0, 0, and they have a constant rate of change. Right? It's going up by 4/3 each time, going up by 1/2, going up by 1/2, going up by 3/1 each time. So how do we know they're proportional? They each go through 0, 0, or the origin, either way. Okay, and they have a constant rate of change. So that's how you know. Graph represents the rate at which Daniel earns points in his video game. The rate Brianna earns points in her video game is represented by the equation y equals 2x, where y is the number of points and x is the number of time is the time in minutes. At these rates, who will earn 100 points first? So we're basically figuring out who has the highest slope for their particular situation, and whichever one has the highest slope will get to 100 points faster. So Brianna's got y equals 2x, boom, and then Daniel has the graph right here. So let's zoom in a little bit. Maybe, yeah, okay. The point 1, 3 represents Daniel's unit rate of 3 points per minute. He's going up by 3 and over by 1. You go up by 6 and over by 2. You can divide that, you get the same thing. You could even go up by 15 and over by 5. 15 divided by 5 is 3, right? So if we put his in an equation, that's going to be y equals 3x, okay? At these rates, who will earn 100 points first? Well, this dude, right? Was it Brian? Daniel. Daniel will reach 100 points faster. Because his unit rate or slope or whatever, rate of change, unit rate, slope, / rate of change, same thing for all these, is higher than Brianna's. There you go. If we wanted to put Brianna's on here, that'd be up to 1/1. So it's half basically. So when she gets to 6, it's actually 3. So she starts at 0, 0, and when it gets up to 12, it's 6, which should be right here. I get that right? I'm not sure like that. And so we can kind of see that hers, when we put it on here, is like this, right? Which is definitely less steep than Daniel. Daniel's right here. Brianna is right here, right? So you can compare two ways, right? You can compare with the graph, and you can compare with the equations, right? This 3x is a steeper slope, so it increases faster. There you go. The graph represents the cost per ounce of a granola cereal. A 15-ounce box of raisin cereal costs $3.90, which cereal costs more per ounce. So let's talk about raisin cereal here. Since it's the verbal description, we'll kind of figure out that. So a 15-ounce box of raisin cereal costs $3.90. So we'll say 15 ounces costs $3.90. So let's figure out our unit rate for this. Basically, it's how much it is per 1 ounce. So it's dollars per ounce. So since it's dollars per ounce, that means we divide dollars per ounce, right? So we take that $3.90 and divide by 15, and that gets us down to 1 ounce, the cost per 1 ounce, right? So we're going to say $3.90 divided by 15. Oops, clear. 3.9 divided by 15 ounces gets us to 26 cents per ounce. Okay, so yeah, just write it down. 26 cents per ounce. Okay, and now for the price of the granola. So you could use points like this or this or this if you wanted to, but you'd have to estimate what it is, right? Because this isn't on the corner, neither is this and neither is this. It goes back to why our table went up by 3, right? Because it generated whole numbers for our y values, for our outputs, right? So it's the same thing, right? So we want to get as close as we can to being on the grid, basically on the corner. We've got a point right here at 0, 0, and we've got a point right here at 20, comma 5. Okay, and so that's 20 ounces, right? Costs $5. Okay, and then, right, so we're going to do that same thing, right? That dollars per ounce, so it's going to be $5 divided by 20. Handy dandy calculator. 5 divided by 20 gets us to 25 cents an ounce. Okay, so which one is, which cereal costs more per ounce? Well, the Raisin Bran costs more per ounce. All right, so the Raisin cereal costs more per ounce. So you'd probably buy the granola unless you really liked raisins, I guess. I'm not a huge fan of either of those cereals, so I wouldn't buy either of them. Look at that. Okay, we got some spiral stuff. This is basically stuff that's not directly related to this in the chapter, but you are going to be seeing throughout the year on tests, so it does not hurt to keep up on this kind of stuff. We've got a 2-step equation right here. You want to take this 4 over here. Since we're adding 4, we basically want to subtract that 4 to balance our equation. We do it on both sides. It cancels out to 0 right here. We're left with 2x equals 12. If you guys like doing this, feel free. Now I've got 2x right here. That means it's multiplication. The opposite of multiplication is division. So we divide by 12 on both sides. 2 divided by 2 is 1, leaving us with 1x, or just x equals 12 divided by 2 is 6. If you wanted to check your work, you'd take that 6 and plug it into the equation. 2 times 6 plus 4 equals 16. 2 times 6 is 12. Plus 4 is 16. Check. Okay. Estimate the value of to 1 decimal place for square root of 72. Square root of 72 is in between square root of 64 and 81, which means it's in between 8 and 9. It is, let's see, 8 away here versus 9, if I could write 9 away here. So it's actually really quite close in the middle, right? So it's like maybe 8.4, 8.5. Let's do an estimate of 8.4, and then we'll actually double check our work using a calculator. So I'm going to say square root. Oops. Why did I do that? Oh, I hate this. Oh, these are good calculators, but for some reason it always does that. I think I need to reset it. So let's use the old calculator on the phone real quick. Actually, you know what? I'm going to use, I wonder if I have the Desmos Scientific Calculator on my phone. I think I do, unless it uninstalled itself. We're good. Okay. I get this guy right here. Boom. Reverse contrast. Oh man, that glare is terrible. So we're going to put square root of, what is it, 72? Yeah. We get 8.48. Yeah, that's close enough. Round that up to 8.5. We're good. We're good. You get 100 points for that on a test, or 100 points. You get full points for that on the test. Find the solution to the following. If we have a square with an area of 25, the side length of it is going to be 5. However, you could also have -5, because -5 times -5 is also positive 25. Now we look at this one, you might think, oh, it's going to be like 5 or -5, right? We have this cube with a volume of 125. We're finding the edge length here. So you'd think it was 5, right? Is one answer, and then -5 as well. But if you look at 5, right, you get 5 times 5 times 5. You get to a positive 125, which is not what we want. So our answer has to be negative, and it can only be negative. Anyway, we're going to pop that in your binder.